Good day, everybody. Welcome to another chemistry series. Now, today I'm going to walk you through stoichiometry in chemistry. Now, quickly, what is stoichiometry? Now, stoichiometry is the branch of chemistry that deals with the study of the relationship between a reactant and the product. Now, let's see a simple reaction, A plus B to give us C. Now, there's a relationship between the reactants. Of course, we know in our beginning of chemistry that the left-hand side is always the reactant and the right-hand side is always the product. Now, there's a relationship between the reactant and the product. What is the relationship? We see that the reactant disappears for the product to appear. Now, for example, let's see fuel or petrol and floater. These are two reactants coming together to react. Now, once they react, the fuel and the floater disappears for gum to appear. Now, the fuel is A, reactant A, the floater is reactant B, and when they react together, it vanishes, and what appears is gum. So the gum is C. So this is the relationship between the reactant and the product. Now also, stoichiometry can be defined as a method which we use to calculate the amount of substances in chemicals. Now, for example, let's assume that we are given a box and you are asked to calculate the number of items in this box. How do you go about it? Is you simply open the box, you pour out all the items and count them one by one and say, okay, these are 3 items. We've calculated the amount of items in the box to be 3. But we cannot open these chemicals to calculate the composition or the substances that makes up these chemicals. So how do we go about it? Now, how we go about it is that we'll first of all look at 2 terminology that is going to assist us towards solve stoichiometry problems. Number 1, we look at a mole. What is a mole? 2, we look at atoms. Now, molar atoms. Quickly, what is a mole? A mole is a word or a unit that quantifies item. Now, for example, if you go to the market and you said you want to buy dozens of eggs, right? Now, with the word dozens of eggs, the seller goes towards the shop and bring 12 eggs. But you did not tell the seller that he wants to get 12 eggs. But the word dozen quantifies the egg, right? So I want you to see, so if you say dozens of eggs, we are talking about what? 12 eggs. If you say 2 dozen of eggs, we are talking about 24 eggs, right? Now I want you to see the word dozen as same thing as mole, because mole does the same thing the word dozen does, right? So we cannot say dozen of sodium chloride. We cannot say dozen of chemical. We cannot say dozen of hydrogen oxide. Instead, we tend to be more scientific or be a good chemistry student when we say 2 moles of sodium chloride, 2 moles of hydrogen oxides. Okay. Now, to give an example for all what I just explained right now, remember, a mole quantifies what? Quantifies an item, right? So note that whenever there's a number at the front of a compound or element, that number stands for the number of moles. For example, if I have 2 NaH. Now, what is the meaning of this 2? 2 here is acting as the number of moles. It's simply telling us that there are 2 NOH. There are two NOH in this place, right? So the word two here is the mole that quantifies what this. So instead of repeating this compound twice, we simply say two moles, right? So if I say we have sodium chloride, 3 moles of sodium chloride. Now, note whenever you see a number at the front of an element or a compound, right? Like we have 5K. Okay, 5K looks like money. So we have, let's say, 5 chloride, right? So whenever you see a number at the front of an element or a compound, front of an element or a compound, that number stand for what? The number of what? Mole. Now, note number two, whenever ever a number is a subscript of an element, that number is regarded as the number of atom. Like you can see here, you can see here, you can even see in this case, this is a compound, right? So this number is acting as the number of what? Atom.